So because you are working so hard, I am going to let you skip this problem. We do not need to do this one today. You have done plenty of challenging problems with composite shapes. I'm going to give you a break and you don't have to do problem number 3. Let's talk about a different type of composite figure though. I want you just to look at this composite figure here. There's more than one shape in this diagram. There's more than one figure in this diagram. I want you to talk with a partner. What shapes do you see in this diagram? Okay, well, I hope that what you said in those discussions is that you saw 2 circles, a smaller circle and a larger circle. These 2 circles are called concentric circles because they share the same center. They both have the same center there, but one is bigger than the other. That makes them concentric. Now, our task with these concentric circles is to calculate the area of the shaded region. It's kind of like we're calculating the area of this donut right here. So now here's another thing for you to talk with your partner about. How could I get the area of just that shaded region? I don't want the little white circle inside. I just want the shaded region. So talk with your partner. How could I find that? Go. All right, guys, let's talk it through. So when you want to find the area of a shaded region and there is a piece in the middle that you don't want to count, you can use subtraction. Let's actually read the problem in entirety here. It says you have worked composite figures by adding areas. Now let's think about subtracting. In the concentric circles shown, R represents the radius of the larger circle, and lowercase r represents the radius of the smaller circle. Suppose that uppercase r is equal to 8 centimeters and lowercase r is equal to 3 centimeters. Calculate the area of the shaded region. Well, all we need to do in order to do that, y'all, is take our big circle and subtract the little circle. We're going to do big minus small. It's almost like we have a circular piece of paper, a large circular piece of paper, and we are just cutting a hole right out of the middle. And the way we cut that hole mathematically is using subtraction. So that's what we want to do right now. So let's talk about that. We made a plan. We said we want to do big minus small. Both circles are going to use the same formula for area. The difference is that they each have a different radius. For the big circle, we would have pi times 8 squared. For the little circle, we would have pi times 3 squared. Now this isn't looking so hard. There's our plan. I'm going to pause the video because you can do this. I want you to work with a partner and figure out the area of the shaded region here by following our plan. If you've hit play, that means you're ready for the answer. When we multiply 8 squared, we get 64. When we multiply 3 squared, we get 9. 64 times pi is 200.96. 9 times pi is 28.26. Now for the exciting part, we're ready to subtract. And when we subtract decimals, we line them up. Nice subtraction, guys. It's going to come out to 172 and 7/10 square centimeters. And just to review, what does that represent? That's our donut. That's our shaded region of these 2 concentric circles. Now, this is a task for you to do with your partner. Here we have a circle inside a square. What I want you to do is come up with a plan for how to find the area of the shaded region. Keep talking with your partner. How could you find the area of the shaded region? Pause the video and talk as a class. What would you do to find the area of the shaded region? You've hit play again, so that means that you're ready to talk about how to find the area of this shaded region. So first, let's make a plan. What we want to do is subtract our smaller shape from our larger shape. So that means we're going to find the area of the square, and we are going to subtract the area of the circle. That's the plan. And you might be thinking, but how can I find the area of the square if I don't know how long its side lengths are? Great question. We do know the radius of the circle. The radius right now is drawn here, but we could also draw it here, couldn't we? The radius is the same everywhere you draw it. So it would be 15 there. And it would also be 15 here. Now, what if I put these together? How far would it be all the way across the circle? It would be 30. So that means 30 meters is the side length of my square. We figured out with just a little bit of logical reasoning. So we have a side length of 30 meters for our square. We have a radius of 15 meters for our circle. We have all the information we need. For the square, we're just going to do the base times the height, and they are the same value. And for the circle, we'll do pi r squared. All right. This one is for you and your partner. Tackle it. You've got this. You can figure this out. So what I want you to do now is take a look at this problem and think about how you would find the area of the shaded region. Okay, you're starting to think about it. Let me show you how two other students found the area of the shaded region. Here's Jimmy's work and here's Matthew's work. Jimmy and Matthew each said that the area of the shaded region is about 402 square inches. What I want you to do is think about how you would do it and then compare your plan with Jimmy and Matthew's. What did they do the same? What did they do different? Which strategy do you prefer? I want you to talk with your partner, think about it, read their work, find the similarities and differences, and then it's your turn to write. You have 3 questions to answer. 1, 2, 3. Pause the video and spend about 8 minutes working on this task with a partner. Hit play when you're ready for the next video.